In this how-to video, we're going to look at how to add and subtract algebraic fractions. The first question we need to ask is, what is an algebraic fraction? And it's simply a fraction that has a pronumeral in it. So if we take the example of a fraction like this, that would not be an algebraic fraction, but if we add a pronumeral to it, it now becomes an algebraic fraction. So what method do we use to add and subtract algebraic fractions? There are a number of steps, and you'll understand these more as we do the examples. However, the first step is to look at the denominators. So that's the number underneath the fraction, and if it needs a common denominator because they're different, we have to create two fractions with the same denominator. Once we've done this, in step 2, that's write them as equivalent fractions with the common denominator, we move on to simplifying the numerator, the top part of the fraction, by adding or subtracting like terms. And finally, if we need to simplify the fraction further, this is where we do it. Now these steps will become clearer as we look at the examples. But one very important question that we have at the end is, does the common denominator have to be the lowest common denominator? And the answer is no. However, you may have to simplify the fraction in the final step before the question is finally completed. So let's go and have a look at some examples of adding or subtracting these algebraic fractions. Here's our first example. We'll take 3x over 5 and we'll add it to x over 5. Now you'll notice that the denominators are the same, so there's nothing more we need to do as far as that's concerned. We can put the numerators over the common denominator and then add them together. 3x plus 1x, collect your like terms, is 4x all over 5, and that's completed. It doesn't need to be simplified. Likewise, we'll do a subtraction. We've got 8a over 3 minus a over 3. And you'll notice in this case the denominators also are the same. So we can put both fractions over the same common denominator, and we have 8a minus a. Subtract these, we get 7a over 3, and there's our final solution. In our third example, we have a slight change. We have x over 4, and we're going to add this with 5x over 6. Now our denominators are different here, so let's just put our fraction here, x over 4, and let's put the other fraction over here, 5x over 6. And we've got to make these numbers the same. It's got to be a number that 4 can divide into and 6 can divide into. In other words, a common denominator. And if you look at it carefully, the smallest number that they both go into is 12. So we actually have to change this into a 12. So if I times this by 3, I need to times the numerator by 3 as well. And if I times this by 2 and also the numerator by 2, it will work. So 4 times 3 is 12, and x times 3 is 3x. So these are now equivalent fractions, and 6 times 2 is 12, and that's 5x times 2, that's 10x. And we can now put them under our common denominator of 12, add the like terms in the numerators, and our solution is 13x over 12. Now remember we said that we could have used any denominator that was common. I could have, for example, gone 4 times 6, and 6 4s are 24, and I could have made these denominators into 24, but it simply means that later on I would have had to have simplified the answer in the fraction here. So you really need to try and get the lowest common denominator in order to create the right answer as quickly as possible. Let's try number 4. We've got 3a over 4 minus a over 8. Now you'll notice here that 4 can go into 8. So if we change 4 into an 8, we actually don't have to change this one at all. So what we'll do is we'll take our 4 and times it by 2, and we'll take our numerator and times this by 2 as well, and then we'll just leave the a over 3 on its own. So we've got 2 3s are 6a over 8 minus a, now that should be an 8, sorry, minus a over 8, and so our common denominator is 8, and we have 6a minus a, which gives me 5a over 8, and there's our solution for number 4. And finally, we'll just do one more example, and so this will be number 5. Let's have a look at this one. We've got 7x over 10 minus x over 3. Now, as we said before, we could take 10 times 3 and our denominator would be 30. But the question we need to ask is there a smaller lowest common denominator, a smaller denominator? And in this case, there isn't, because if we look at the number 10 and we go up in multiples of 10, we'll notice that 3 doesn't go into 10, 3 doesn't go into 20, it only goes into 30. So in fact, multiplying the denominators together in this case gave us the lowest common multiple. So we're going to change a 10 into a 30, and here we're going to change the 3 into a 30. So we need to multiply by the same amount at the top in the numerator, and in this case by 10. So we end up with 21x over 30 minus 10x over 30. Our common denominator is 30, so it's 21x, take away our like terms here, 10x, and our final answer, 21 take 10, is 11x over 30. And we'll just have a quick look at the answer to see if it can be simplified down. 11 over 30, there are no common factors, so that will be our solution.